Hi everyone. So yesterday we looked at uniform rods and at moments and when the rod's in equilibrium. And so what we're going to do today, we're going to look at non-uniform rods and non-uniform planks or beams or whatever it might be. And you'll know from yesterday's notes, if you've read yesterday's notes, it tells us that the centre of mass, if the rod is non-uniform, is not at the midpoint anymore. So again, just like with yesterday when it said uniform, that was important. Today in these questions, if we get an exam question, that's really important that we have a look for that term. It's non-uniform, so we need to remember then that the weight is definitely not acting at the centre of this rod. Okay, so let's have a look at this question. So two children are sitting on a non-uniform plank, AB, which is the plank's got mass 24 kilograms, but it's not acting at the centre, let's remember, and it's got length 2 meters. The plank, it tells us, is pivoted at its midpoint, so it's like a seesaw basically, but it's not a uniform plank. The centre of mass of AB is at C, where AC is 0.8 metres, so not in the middle of this. I'm going to draw a diagram in a second. One of the children has mass 24 kilograms, sits at that end A, and the other has mass 30 kilograms. And we're asked to find out where this second child should sit so that the plank remains horizontal, so basically remains in equilibrium, so the sum of the moments is 0. Let's draw this diagram to see what it looks like though. And as we said yesterday, sometimes in questions they might give you the diagram, sometimes they might not. So we've got this plank of wood or whatever, AB, and we're told that that is 2 meters. So let's just get that on our diagram to remind ourselves of that. It then says it is pivoted at the midpoint. So let's just get our midpoint on there, and we've got this pivot point. So from what we looked at yesterday, we know that there's going to be a reaction at that pivot point there. So I'll call that RM. Okay, let's get the rest of this information on. The centre of mass then, AB, is at C, where AC is 0.8 metres. So this distance is going to be 1 metre. So 0.8 is going to be somewhere around here. It's not drawn to scale or anything like that. That's my point C. And that's where the mass of this rod, the weight of this rod is acting. So this 24 kilograms, that's going to give me a force there, a weight acting downwards, 24G. The next bit of the question, then one of these children has mass 24 and sits at A, and the other's got mass 30. So let's put the one who's sitting at A, and that one's going to have a downward force there of 24G. And then the other one, it says the other child is going to sit here. I'm just going to put some distances on while I remember. AC, we're told here, is 0.8, so let's get that on. 0.8 metres, which means this is 0.2 metres. And then the other child's got to sit somewhere that balances this off. Obviously, if there was nobody on this thing is definitely going to tilt that way. So we need to get this other child on here somewhere. They're a little bit heavier as well. So we need to get them on here somewhere so that balances these two, the moments of these two in this direction, the anti-clockwise direction, and pulls this way. And we don't know where that's going to go, so we're just going to shove this on. It doesn't matter where you put it, but let's go. There is my other child. Okay, and that's got this weight acting downwards, 30G, and we're asked to find where should they sit. So I'm going to call this distance X. We could call this distance X, it doesn't matter. I'm going to call that distance X, and then we're going to find out what this distance is, so we can say the second child must sit so many meters from the midpoint, or we could take it away from 1, couldn't we, and get this distance here, so this being 1 meter as well. Okay, let's have a look at this then. I'm going to take moments about M because that makes sense to me, because then again, a bit like that question that we saw yesterday, if I take moments about this point, this reaction force isn't going to have any turning effect, so that doesn't come into my moments equation, so I can just kind of ignore that if I take moments about this point. Moments about any other point would have to have this reaction force involved, which would be okay, but I might have to then do simultaneous equations, which is what's actually going to happen in the second question we do today. So let's do this then. I'm going to tell the examiner I'm taking moments about point A, about point M, that midpoint there. And what am I going to do? I'm going to do my usual. I'm going to take clockwise as positive, but I'm telling the examiner that so that then they can see what I'm trying to do in all of this. Okay, so let's have a look at this moments about M. So this 30G is going to be pulling us clockwise, so that's going to be positive. And then these other two 224Gs, are both pulling us anti-clockwise, so they're just going to be negative in terms of moments. So let's look at our moments added together. The 30G then clockwise, that's positive. Perpendicular distance from M is this unknown X. Then we've got this minus 24, minus because it's going in the anti-clockwise direction. 24G is my force, 0.2 is my perpendicular distance from point M. And then this one, again, negative because it's pulling anti-clockwise, tending to turn us in the anti-clockwise direction. 24G, and this time times this full distance, this full 1 metre to M there. And the sum of those is going to give us 0, because that's what we want. We want this equilibrium. We want this to be stationary like that, where these children are balanced on this plank. So there's our equation. Let's just sort through this. So 30gx minus 4.8g minus 24g is 0. So 30gx is going to give me 28.8g. So x is going to be my 28.8g over my 30g. Those g's will cancel, and that's going to give me, let's just see, 28.8 divided by 30, 0.96. So x is 0.96 metres. And then let's just answer this in a sentence, so that second child must sit, and we can either say 0.96 metres from the centre M, or we could say 0.04 metres from endpoint B. And this just kind of depends on the question. This one doesn't say, so either of these would be fine. Just be careful if the question says, how far must the child sit from B? Then, you need to make sure you're doing this bit. Okay, so that's our first question done. Our second question, really similar sort of situation, non-uniform rod, etc. But we're going to have two pivot points here. We're going to have 2 points that have reaction force, and we're going to need to do some simultaneous equations.